Hello, thanks for joining this webinar. This webinar will be, so thanks for joining the call. This webinar will be recorded. All participants will be muted. The slides and the recording will be sent after the webinar. Please be patient as we won't send it right away. We'll be doing a couple of editions. If you have any questions during the webinar, don't hesitate to ask them through the chat. We will be talking today about the digital transition for water utility. And we will be tackling it from different viewpoints. Andrew Forsyth from Southeast Water will take the angle from the water utility side of what water digital transition brings to the table. IoT Europe will present what technologies are made available today to overcome some of the digital transitions hurdles. Mark Atkinson will be presenting the solutions that and the customer experience that digital transition offers to water utilities for their customers. And last, David Award from Itron will present how to choose the right device manufacturer and how to ensure the success and what are the key technical points that you need to assess for your devices to be on the digital transition. So let me start by introducing and letting every of the presenter to present themselves. So Andrew, will you start presenting?
Hi, Olivia. Hi, everyone. My name's Andrew Forsyth, General Manager of the Digital Utility at Southeast Water in Melbourne, Australia. Looking forward to outlining a little bit about our digital strategy, some technology selection decisions we made, and looking at some real world examples of how we're undertaking digital transformation in our business. Thanks.
Mark, have you been able to join? So we have some trouble with Mark. Mark has some trouble with his mic, so I'll pass you the mic, David, to present yourself.
Hi, David Howard, Itron Idea Labs. I have worked with lightweight M2M for a few years through its development, and we'll kind of present how it can be used and why it should be used for low energy devices like water meters.
And I'm seeing that Mark is back. So Mark, will you be able to? If you are talking now, Mark, I'm not able to hear you.
Yes, Mark Atkinson, can you hear me now?
Yeah, it's really faint, so be loud.
Sorry, my apologies. Yeah, I've just had to reboot my laptop. My apologies for that.
Yeah.
Mark Atkinson, I'm domain lead for industrial IoT at Telstra. I mean, I'll talk a little bit later on about that, and I'll talk today in a slightly different angle than what we normally do. I'll be covering off how we've taken lessons from our own digital engagement and digital transformation and how we apply that to water utilities to assist them.
Thanks, Mark. And let's see if we can fix that microphone problem. And I'm Olivier Carmona. I'm in charge of sales and marketing at IoT Europe. We have been working in digital water since a couple of years now, and we have been helping scaling massively the IoT devices that are around this particular smart water meters. We will be discussing about what we have been working and enabling in this ecosystem. And I'd like to give the floor to Andrew to start the presentation. So please start.
Thanks, Olivia. Hopefully everyone can see my slide deck there. So yeah, as I said in the intro, today I'm hoping to give some real world examples and give a water utility perspective of how IoT is transforming our business, which it definitely is. And obviously we're in our infancy, but we've got really big plans for how it's going to change us going forward. So just a little bit about South East Water, who we are. So we deliver water, sewage and recycle services to about 1.9 million people in the southeast of Melbourne. So that green area is the southeastern region of Melbourne, a really diverse geographical area with sort of high-rise central business district going down to sort of farmlands, down to holiday homes and everything in between. In terms of asset base, pretty typical of most water authorities, but thousands of kilometres of pipes, lots of pump stations, tanks, etc., all what you'd consider traditional assets. On the sort of new wave, we've got quite a few thousand battery-powered IoT devices already in our fleet and being used to great effect. But the big picture for us is in the next 5 years, that'll grow to about 1 million devices. So all our plans are around how to deliver that, scale it, and then make use of that data to sort of transform our business. So our digital transformation strategy is really about two things. It's about, firstly, giving our customers a better experience by empowering them with data, which sounds pretty simple, but if you compare us to our sort of peer industries, etc., we look pretty antiquated in terms of what we can tell our customers about our product, when and where they use it. So we really need to up our game on there. And the second point is about transforming the way we manage our networks to become predictive rather than reactive. And so hopefully today, in some of the examples, I can show you how we're planning to do that. When we set out our digital utility vision, it quickly became apparent that it would impact the entire business. So rather than it being a technology project done in isolation, we set about creating a business transformation initiative that was based on digitizing our networks. From the outset, we estimated that this transformation would impact somewhere in the vicinity of 60 to 70% of our existing systems and processes. And as you can sort of see in the picture there, every facet of our business and operation is going to be affected by digital transformation. It touches on the customer side, the asset side, everything in between, trade, waste, all of those good things. So probably not rocket science to say that, but when you look at it and sort of deem that it's not just an IT or an OT project done on the side, that it is actually cutting across the whole business, it was really important that we brought our people along on that journey. And the culture change is as big a part of that as anything. We always engage with our customers at South East Water, and we want to work out what they value from us. In the last engagement we did with them, they came up with 5 clear priorities. And when we unpacked these, so they're in the circles there, as you can see, we felt that IoT and digital transformation will go a long way to us being able to address these concerns. So things like warn me, inform me, it's about giving them early indications that something's going wrong, either on their bill to prevent bill shock, for example, or something in our network, so they don't get an interruption and a really poor experience. So we felt IoT is not the silver bullet for all of these things, of course, but it touches on lots of aspects. So that was really heartening to see that our strategy was basically what our customers would value. We had to make some strategic decisions along the way, as all companies do, especially around the technology stack. Obviously, the technology, at the end of the day, it's an enabler for what we want to do, but it's a pretty important enabler given that there's so much competition out there and different merits for different technologies. So we try to do our due diligence on that. And so what we were after is an open standards-based approach to all the links in the IoT chain. So what I mean by that is devices, telco networks, head-end systems and analytics. We wanted those to be all interchangeable if needed, and to give us that flexibility in that competition. We wanted future-proof, low-power, wide area connectivity, and we selected NB-IoT, which is part of the 5G stack. I'll touch on that, the reasons why, a bit more later. And we're after secure, extensible, well-supported protocol stack that could handle everything we wanted to do with these devices. So obviously sending data, but things like firmware over the air, configuration, all the things we could think of to really help future-proof us. And it led us towards lightweight M2M, and that's what we've embedded both in meters, but all other IoT devices in our network. We took a cloud-first approach to data acquisition, storage, and analytics. So that's the lightweight M2M servers. We use the Microsoft Azure IoT stack. And the end result is a simplified architecture where no matter what device fleet we're talking to, whether it's meters, manhole sensors, water quality, trash cans, whatever it is, it's all governed by the same simple architecture and simple systems, and you manage your devices in a consistent manner. The cloud also allowed us to, with that compute power and the scaling, it grows as your fleet grows. So you're not having big sunk investments up front and then trying to grow later. So that cloud approach and that OpEx model really worked for us. And then all of the automation and orchestration behind the scenes, either building new processes that didn't exist before or digitizing legacy processes. So we've used some tools for that one as well. In terms of the devices themselves, as I mentioned, they're all lightweight M2M client based, and for digital metering, that was our primary focus. It allowed for efficient battery life. You can really tweak and flex the lightweight M2M protocol so that it only gives you what you want. And in our case, we want the meters to sleep most of the day and just give us that really informed packet once a day. In our case, that's full of all of the interval data and events and alarms. And it also gives you that flexibility. In our case, I'm going to talk to it about how we added extra sensors that sort of aren't out of the box metrology or metering applications. They're slightly different, and the protocol we selected allowed us to have the flexibility to adapt and use those. So just quickly, why we chose NB-IoT, secure and future-proof. I mentioned we wanted telco-grade communications. For us, this is critical infrastructure. It's either billing, so from the revenue side of our business, super critical, but also if whatever we're monitoring, there's a reason for it. We want it to be as best and robust as possible. So we wanted a trusted operator to take care of that side of it for us. Coverage, here in Melbourne, we've got 3 carriers, all with NB-IoT coverage. So we felt it was a really good future-proof solution, especially with NB-IoT part of the 5G stack going forward. Standards-based, we don't want to have to invent and build everything here. We want to import innovation and just a global growing ecosystem based on a standard. We're starting to see that come to fruition now, so that's working well. Low cost, low power, mentioned that around sort of 10+ year life required for our business case for our meters. And the last point there, just about two-way communications. Firmware, config, acknowledge message, just to name a few. Yes, there's some trade-offs in terms of having that two-way comms, but we figured the benefits far outweigh the negatives there. So that was a requirement for us as well. And the other point is we wanted to sort of stick to our knitting on this. We didn't want to be building radio infrastructure and managing and maintaining it. We just want a plug and play solution, and NB-IoT is effectively allowed for that. So just a little bit on our program. I won't go into this too much, but probably 2 key aspects probably that have been winners. And this is from purely customer metering perspective. And it's not anything, not rocket science, but it is new to our business because we haven't had it before. And that is leak detection. So notified leaks to customers. There is some sophistication around business logic before we do send a message out to customers. We sort of quantify the size of the leak and the message we're going to send to them so that it's sort of fit for purpose. But that's the real winner so far. It's just a great customer experience to get an alert telling you you've got a leak and being able to fix it rather than the alternative of finding out at the time of bill and having that poor experience, bill shock, and just a bad taste in your mouth with your water company that couldn't tell you about that. The other point just to note, and I guess a somewhat contentious smart metering, if you like, in Australia, but install and refusal. So across our install base so far, we've had really good support from the customers with very small, as you can see, 0.16% refusal rate. And that's generally people that just weren't interested in being part of our initial rollout. And so we respected that. But generally speaking, we've had no pushback thus far. So just a real world example here, and this is one of many, probably hundreds, if not thousands now that we could have showed. But this one, if you look at the green graph down the bottom, that's, mouse wheel. The green graph down the bottom there, that's showing the flow through a meter in half-hour intervals. And as you can see, that's pretty much maxed out at around 1,000 litres every half an hour. So you think, how can this happen at a residential house? It was actually a broken pipe running under the house, running to stormwater. So the customer never saw it, but it was running as fast as it possibly could. We obviously alerted them and fixed it. And as you can see, it's probably off the scale there because it's dropped so low that it was rectified really quickly. And like I said, that's an extreme example, but there's everything in between, from leaking toilets and taps through to these sort of extreme ones. The other things we can give our customers now is just that sort of rich billing interface, just showing where your data is, matching it to temperature, breaking it down by days, slicing and dicing. Now, of course, not everyone's going to be interested in this side of things, so we definitely think the real-time notification via text and via apps, etc., is probably the future. But for those that are interested in it, that data is fully available there. So when we're trying to initiate demand reduction initiatives and things like that, we've got the tools now to do that. So a little bit about the meters in the case that we're using. So like I said, it's enabled us to use extra sensors. That black box you see in there is an extra MEMS-based sensor, if you like, that's doing more than just metering, and I'll talk to that in a minute. But lightweight M2M was key to that, because on demand we can extract waveforms or big data sets from that particular little device in there, and pressure, reverse flow, all these other bells and whistles from the meter we can get, and you can flex that as you needed with lightweight M2M. So that payload can be as small and efficient as you want, but when the time's right, when you want particular information in an ad hoc basis, it also allows for that. And the firmware over the air, obviously you hope not to use that in anger too much given battery life and everything else, but we've already used it in a small scale to fix some sort of edge case issues in our meter fleet. So it's already sort of paid for itself of having that flexibility. So I'll just touch on that, the little black device in there, for example. So that's effectively a vibration sensor baked into the meter. So the benefit is purely for the Southeast Water side of the network. So not so much for the customer in this case, but it's in the customer meter. So on the left-hand side, you see the red and green dots there, customer meters that are sensing the vibration on the network side. So listening for leaks effectively in the street, either on the pipe connecting service pipe into the property or on the main itself. So just visually on that left-hand side, the fact that all of those houses lit up in the morning to say, we can all hear something, that told us straight away, without any sort of algorithm or machine learning needed at this point in time, that there's very likely a mains leak that's affecting all of those properties. And that was the case. It was rectified, and on the right-hand side, you see the houses returning to normal, all those green dots. So we've had hundreds of examples of this sort of nature where we're seeing leaks well before they become bursts, which is sort of that holy grail period for certain pipe materials where you can intervene early. So it's not just about that being more predictive, but it also in the future is going to allow us to optimize the way we react to those leaks and fix them. We can potentially batch them up because we'll have all this information at a desktop level each day. We can optimize our maintenance fleets to go out to certain areas and fix known problems long before they've impacted customers. So it's a real game changer from our perspective. And just another real world application of that technology is when we've had pipe bursts and leaks repaired. They usually get fixed, they get patched up, buried away, and we don't hear about them again until they become another issue. Having these sensors everywhere, it's actually acts as a warranty system for repairs. So in this example here, a repair was made, a clamp was put on, contractor finished, and then the very next day, the technology was showing us that there's still a problem there. So we were able to get the contractor back under warranty to fix effectively a shoddy repair in this case where it wasn't done correctly. So I guess in summary, lots of application now on the back of our IoT strategy coming to bear, both on the customer side and on the network side. All of them have the flow-on effect to add value to customers. So even all that network stuff, which is predominantly a Southeast Water benefit, ultimately that benefits our customers if we can provide lower cost to serve of all of these for all of our assets. So yeah, look, hopefully that's a bit of a flavour of what we're doing in the IoT space. And that's it for me. Thank you.
Thank you, Andrew. Thank you. So I'll start the presentation. So a lot of foods for thought here. And I'll start presenting for our side. So you may not be familiar with IoT Hub, so let me introduce you shortly. We are a private company headquartered in France with sales representatives in Taiwan, Singapore, New Zealand, Germany, and Netherlands. We have always been in the business of IoT device management, focusing on massive IoT deployment. We always have been of the opinion that to scale massively IoT, you must automate the life cycle of device while keeping power efficiency and minimizing the communication. So we have also been always of the opinion that rather to invent a proprietary solution, we should contribute to a standard, and we have worked in many, and in particular in Open Mobile Alliance, alias OMA SpecWorks, and up to become an elected member of the board. In addition, to achieve the best product, we managed to convince the leaders in their respective fields worldwide to work with us. We have been working since years with leaders in telecom like Ericsson, with the leader in cellular IoT module, Thales, with the leader in smart metering and street lighting, with automotive leaders, Stellantis. But today, we will focus on one particular field, the water utility. So water utility is under pressure to become digital. First and foremost, a lot of economies are ahead. Bluefield research that has been innovated previously forecasts that digital utilities can generate savings of 20% to 40% of the total cost. How can they do that? First, by reducing manual operation, not only because being able to remotely operate saves time to your team, but also because it addresses the aging workforce. 38% of utility employees will be eligible to retire in the next decade. Second, big data, like Andrew just showed before, can help you run predictive maintenance. This is of utmost importance. Water utility face worldwide aging infrastructures. 45% of the existing infrastructure is near to the end of its useful life. Plus, as Andrew showed up, and Mark will be also insisting on that, subscribers want to monitor the water consumption. They want to be notified in case of leak, and the same way as they can do it right now with their over power consumptions and in general their expenses. And last, water utility business is changing from an infrastructure operator to a service provider, and that digitization helps to monetize your services in a much flexible way. Many cities now want a service paid per operation rather than just an annual fee per device. The digitization can help you in doing that. So digitization comes at a price. I will not mention connectivity infrastructure cost, the cost you pay to keep your device connected, because already mentioned it a bit with Narrowband-IoT. My interpretation of these results are that when an existing Narrowband-IoT infrastructure is here, you will be better to use it rather than pay to maintain your own private LoRa or private 5G network. Your business is sufficiently complex that you need to run your own telco service. And I will encourage you to watch also our March webinar on smart water metering, and the recording is available on our website. So connectivity set aside, most of your costs will come to maintain heterogeneous fleets of connected devices. This requires to collect plenty of data from a plethora of vendors, sensors, each with their proprietary format. Today, you are in a situation where you are strongly dependent from those device manufacturers. Each of them offer you to access their devices through their own proprietary cloud front end, and you need to build a translation between all those devices, and worse, the translation needs to change all the time because they keep changing format after each new feature addition. Worse, it makes security hard to audit due to the combination of those multiple cloud frontends, and their permanent version changes makes every manufacturer a potential hole in your IT system. This is too bad because at the same time, the need for constant maintenance is growing. Attacks on utilities are increasing day, night, weekdays, and holidays. And today, the maintenance of your smart meters, your water quality sensor, your water tank level sensor is very expensive. Though we are in a direction of getting digital since 30 years, the growth of operating costs during this period increased like never. There are way too many interventions due to field operations caused by faulty networks or smartness. For field operation requires too much networks expertise. And would it be to conduct just an installation or dismantling or repairing those smart devices? And the operation is done remotely. Your only tools are to do operation device by device, using a human operator to do command line operations on prompt. Remote operation is not necessarily something that is helpful if it's done device per device. So to roll out millions of devices, if you cannot ensure that they can be installed simply and automatically, you will be in a very difficult to roll out security update, to install millions of devices, to or remotely operate them. And even how can be guaranteed that your meter data will be transmitted? So this is what device management is for, and not a proper device management offered by each vendor and that is partially implementing its own definition of device management, but a standardized one, unified on your overall fleet. To us, a device management must carry touchless secure network installation. It is not the business of your field operator to have a PhD in telecommunication. This is not of the business of your personnel to conduct firmware update device per device by logging on the device. Now it's the job to scrutinize tons of logs to check if a device has been updated. It's not the business of your team to be up at 2 a.m. to drive a basic response on an alarm that is regularly happening and for which a fix exists thanks to a set of operations. But it is your business to be able to change your customers for the maintenance you are connecting and even for the per operation if they ask for it, even pay per operation if they ask for it. Last, although this is rather aside from device management, what if you could unify your data formats across your whole fleet of smart meters or sensors in general? What if you use the same interval data delivery objects for all smart meters, the same even data delivery object? This is already the case for Southeast Water because they adopted lightweight M2M. The lightweight M2M, and we had an introduction by Andrew just before, but lightweight M has been around since many years already. It has been deployed initially on billions of M2M devices. It is a must for telecom service providers. It allows them to monitor the quality of their service, and hence, logically, its efficiency made it the best solution for water, electricity, heat, and gas network operators. IoT Europe has been at the head of this change with Itron, with Southeast Water, and with Telstra. We have not only experienced during many years how to deploy it over Narrowband-IoT, but we've also been key at the Open Mobile Alliance to work on the lightweight M specification to make it appropriate. Reason why we have been elected by our peer to be a member of the board of directors at OMA. We have not only built the standard, but we have built the best product to address the real need of our customers. Alaska can scale to millions, as we have experienced, and because we have built to the latest cloud microservices, Kafka, Redis, and MongoDB. Alaska supports lifecycle from touchless provisioning up to firmware update over VOR campaigns, even in difficult network conditions. We can also proceed to FOTA campaign on selectable group and dynamically change in adequation with cell saturation situation. Alarm can trigger automatic set of programmed action to lower maintenance burden. Data can be orchestrated remotely to match dynamically your need, moving from an instant value to an average value, for instance. And on top of Alaska, we provide also Iowa, an embedded client that can make any platform lightweight M2M ready. Iowa is a C library code already ported to many embedded OSs, and that can be ported even to bare metal devices, and then can put the latest lightweight M2M features in the most affordable devices. It implements the most efficient power schemes, delivering as much as 70% more lifetime and 50% less data compared to alternatives. So we bring you a solution to scale massively IoT development. We help digital water utility to provide touchless installation at initial bootstrap with a final firmware with production server address, so that you don't have any IP that will be staying at your manufacturer. You will be only then provide critical production server address at production, and you can be able to wipe out the initial manufacturer firmware. You can significantly lower your expenditures by relying on automatic operation, and by extending battery lifetime, you can at last master your data dynamically and hence improve its quality for better business application. But Alaska helps also at development stage. Alaska and Iowa have been very well documented. Customers have been able to implement our solutions in hours and have always found an expert support at their side to answer any deployment questions worldwide related to lightweight M2M or Narrowband-IoT or any cellular IoT technology. We have been developing solutions worldwide for smart water, for heat meters, for container tracking, for city lighting, or for smart building sensor. We have been working in different fields, in different places. We have been experienced in offering those solutions. We're using Iowa sometimes, Iowa and Alaska in other times. We are really been experienced in offering those solutions worldwide. And I think that we have proved that lightweight M2M can drastically reduce your operating cost, but also that it can work on affordable battery operated devices. It's not only a solution that you need for machine to machine, it's a solution that brings you much more than that for your IoT device, for constrained devices on constrained networks. And IoT Europe have been building the most energy efficient solution, and since then I've been able to test it worldwide. The same way we have had our partner, we can help you reduce your cost, talk to us, and grab your market. I'd like now to pass the ball to Mark. Mark, can you hear us? Mark?
Can you hear me okay?
Yeah, perfect. So I'll be passing the slides if you're okay.
I've still got a laptop problem. Are you okay to, you've got the presentation, would you like to present and I'll talk through? Or
you can just tell me next. I have your presentation is starting. Can you see it?
yeah, so hi, it's Mark Atkinson. Firstly, my apologies. I'm a little bit technically challenged, which is embarrassing for a telco, but so I'm going to move on here. I'll talk today about a slightly different topic. It's around digital engagement for a water utility. And coming from a telco, that's a sort of an interesting scenario to talk. But Telstra, in terms of a carrier, is Australia's largest IoT network. And you can see there the sort of size. Do you want to just hit the sidebar there? And it'll come up with another. Yep. And just to give people a comparison, if you're not familiar with the Australian environment, I know there's a couple of people on from Asian countries as well and Europe. So you can see the size of what we're talking about. Really, it's from sort of like London to well and truly past Istanbul into Syria, and from basically Cairo, up into Sweden in terms of size. So it's a very diverse scope, and you can see the amount of coverage that we provide across the country. But we'll do that as best we can. Next slide. But given that we are a carrier, what would a telco know about digital transformation? How do we help you as a water company? What we've done in the way we've looked at this is we've taken the experience that we have in the utility space, and we are a regulated utility in the way that we operate, and we've taken that scenario where we do that in an agile and highly competitive market and said, how can we bring those things to the advantage of, for example, water utilities? So, we understand as a utility how important it is to get things right the first time. We understand the full impact of when you're going through transformation, and in terms of cost, schedule, people, process, it's much more than just buying new equipment. And we're also able to help people go live and implement in terms of both scale and speed. Obviously, when you're a big utility, speed's possibly something that's a little bit different. We focus a lot on outcomes, as you have to in the telecom business, and we do that, and we help that as a utility to help you do that as well. So you're going to collect lots and lots of data. So you're going to go from a manual read every 3 months, maybe 6 months, to getting information every 30 minutes to 1 hour a day about your data, your meters. So you've got lots of information, and you need to turn that into actionable information you can use rather than just a pile of data. And it's important there we help understand the end-to-end process, deal in complex data sets, and present them to management in a way that they can be readily digested and used for rapid and valid decision making. And we recognise that the end customer is a really key part of the overall solution, and they need to be meaningfully engaged. And telcos really understand this meaningful engagement, and we'll talk through that a little bit later for you to be successful. And then we talk about the capabilities that we have, leveraging scalable architecture and solutions that as we use, having a native understanding of digital connectivity with your customer. And very importantly, and we've done this already with a number of local councils and a couple of utilities in Australia in partnership with some industry experts, helping you develop a business case that gets things across the line. So this is the sort of information a telco can bring to you as part of your solution. Next slide. So in terms of phasing IoT value, we all understand IoT is involving connecting things and analysing things. But one of the key things we forget is also about engaging the people, your internal people and resources who will help you manage, and also your end customers. And it's really interesting. I'm in the IoT Alliance Australia, and we just presented some awards this week about some IoT projects. One of them was to Sydney Water, so congratulations to those people if they're out there. But you know, it was about engaging their teams to be more effective in the way they're helping to manage. And the experience we've had in that IoT Alliance has been, it's all about that engagement that makes IoT projects successful. If you just focus on technology, you know, you don't get the full benefit. Next slide. So I'll talk to the next slide. It's in terms of, you know, looking at the Telstra digital water metering solution. You know, what does it look like? Why Telstra? A lot of this is very common with what you see with different solutions that come up. But the three critical ones are, I'm showing here in the green boxes. One is to improve the customer experience, which is a lot more than just presenting the bill. And I'll talk to that a little bit later on. Another is shifting customer behaviour and doing that in a way that you're engaging the customer and helping them behave in a positive way to make those changes. And as telcos, we really understand that because our customers are volunteers. They can simply get up and move away to someone else at any time. So we really need to have to engage them in a positive fashion, okay? And of course, having done that, we're then able to manage demand and do things that are really important to us as utilities, like save water and ensure water security. And then the last important bullet about the way that Telstra tackles this problem from our direction is that we're looking at the smart utility of the future. So we're not just looking at, can I use my water meter to do mass market residential billing? It's what are the other things that I'm able to do with that so I can become a completely transformed into a digital utility, and things that I can do around that to drive, you know, better performance of my various KPIs. And I'll talk to that a little bit later as well. Next slide. So the next slide is actually, if you like, a business view of what we're doing, and you'll get used to this, you know, collect, analyze, and engage model. It shows the entire water scenario from our perspective and what we do. I won't cover the collect side that much in looking at this, but you can see it's about, you know, accessing long, and we're very familiar with, and Andrew talked about this as well, you know, devices with very long battery life out in the field, the ability to bring as many devices as possible in and provide ecosystems. It's an ability about having a rock solid, secure and quality network for data transmission. Telstra runs an NB-IoT network. Our solution is capable of managing devices on other networks as well. We run the largest IoT network. And as I said, I won't talk about those at great length. When we look at analysing, we bring that data in a scalable fashion. We're able to then use that and analyse it to bring you with outcomes. And then we get to that engagement side of the diagram. The critical part of that becomes how you drive demand management, so how you do that engagement, how you increase customer interaction, how you put information in their hands, and importantly, the analytics around that. Next slide. As we look at how we might do that moving forward, we find that, you know, one of the things we do when we're helping our customers is to look at, hey, you know, mass market metering. You know, smart water meters is often the first thing that particularly local councils come to us about, and often large utilities. But sometimes it's a clever solution you need to find that might give you a really high bang for your buck return as part of that. And this outlines a bit of a partnership solution that we've done in the market here, which is quite innovative. It's done in collaboration with the industry. So the water utilities, intelligent water networks, and universities coming up with an outcome that makes a huge difference in terms of blockage detection and spill detection. For one of our customers, there's about $300,000 of avoided costs in incidents per month. I think my team tell me this is a 10-minute install, but I'm sure the customer will tell you that there's a whole lot of preparation time and a whole lot of other things to go into getting ready for that 10 minutes. But this is just an example of, you know, once you're getting systems out there and you're using the solution, it's not necessarily just about getting a smart water meter. There's a lot of other things that can be done when you're enabling your solution. Next slide. Thanks, Olivia. So then I'm going to look at it through the lens of two different views. One is the architectural view and one is the sort of services model, just so you get a perspective. I'm not going to cover collection. I'm normally, as a telco, I'm covering a lot about collection, NB-IoT, why NB-IoT, why Telstra's NB-IoT. Let's just take it at this point in time that the collection is rock solid. Another thing that we do is we provide an IoT platform, which allows us to validate and to manage data and manage the collection process. But again, let's assume that all that's working and it's great. So basically you're running a digital utility that's able to collect a lot of data. But what do you actually do with that? So a critical thing for us is this digital engagement scenario. And what does digital engagement really mean? So digital engagement here is about, in that green box, accessing your customers and the public, your water operations teams and other teams, and your administration to be able to make your system perform in the best way and get all the participants in the system, which is not just technology, but people, as part of those resources to be successful. So you need digital channels and presentation to people in the best possible way, and we'll talk to that in a minute. You need analytics, which is a way of digging down into that data store, and I think Andrew gave a couple of good examples from the experience of Southeast Water of how you do that analytics to give you an outcome. Likewise, the previous example around the sewage monitoring is another one where you're looking at the flow or the height of water in a sewer and being able to make determination from that and take action from it. And then the third one is automation. So what you want to do is minimize the engagement of individuals in the process so that you're able to be more efficient and send information out based on the analytics you've done. You might send something to a customer and suggest that, hey, you've probably got a water leak because we can't believe how much water is actually going through your meter. You might send information out, to your water operations team that, hey, it looks like the sewer could be full. Or it might be information to your administrators, simply that someone needs to go to the field because this meter's failed. Okay, so you want to automate those processes as much as possible. Next slide. So then we look at that through the lens of the actual services model that we're using. And in the services model, you'll see here a slightly different presentation. It's a classic presentation of services models, but you've got the services along the bottom, you've got the software solution in the center, and you've got the other parts of your solution across the top. What's important in the software solution is that your operations people are what you're normally seeing in here, the admin portal, the analytics engine, demand management. They're the typical things that you might be doing, or event management. The green box, again, showing you what we're introducing here from our experience in the telecom game about how to drive people as part of a solution that you need. So here we've got, mobile applications, we've got displaying usage, notifications out to people, be they by a text, be they by an app push, via an email, whatever you like, but ways to reach the people in a way that they're going to react well and react on time. An ability to set targets. So, for example, in my water authority, they talk about 155 litres per day per person as the target that we should be using for consumption. Can I meet that target? Behavioural challenges. Mark, you're not meeting that target. You're above it. So what can I do to actually stay under that target? And then gamification, which says, well, everybody else has met 155. How come you haven't? And giving me opportunities to get rewards for meeting that target. So, for example, 3 months in a row, I get a pat on the back, or I get a discount or a voucher for something. But a way to keep me engaged in being part of that overall solution in meeting the targets. Next slide. So we start to getting down towards the money game around how that works. So the approach here is to get the engagement on a long-lasting basis by forming a partnership with customers. And as I mentioned, I'll go back to this telecom roots. This is a really critical part of how we get this solution working. And it's much more than just a portal. So traditionally, portals are interesting things that provide people information, typically in a one-dimensional way. And they're generally used very quickly by people when you first launch a billing portal or something like that. But the interest and use of it drops off really fast. So we've got to find a way to personalize that engagement with water-wise services and get that engagement to continue ongoing in a year-round type initiative. So, for example, in summer, you've got higher focus on water consumption than you might in winter. So The platform that we're looking at and leveraging our experience at telco throws out learning challenges to your customer base. So it lets them understand, what consumption looks like. What's the difference if you're in Australia, people water their gardens a lot. What's the impact of that? It allows you to make pledges, like in my case, 155 litres per day per person in the house. It gives you an ability to have verifiable action and feedback. So yes, you made 155 litres today, because I know how many people in your house, or you didn't. And provide rewards. You've been successful for all through the summer, and now you're going to get a reward of, something free or a discount off your bill or something like that. So these are really important ways to keep that engagement going along the way, as opposed to a flat presentation on a portal. And then we look at what comes out of that. It's your ability to better manage demand by leveraging the actual behaviour of all the people who are in your system. It's an ability to improve sustainability, so you can create initiatives around that, education and events. It's works that you can actually support your works teams, and I'll show an example of that a little bit later. And of course, civic engagement. This is where you've got, participation of people. I'm a scout leader. We take our scouts down and we help clear waterways, for example, and you can promote that and get people to engage. Okay, next slide. So the way we do that in terms of implementation is we take the digital water utility that we've created in those earlier slides, looking at from different perspectives, the business, the architecture, and the services. We deliver across that water literacy and education for your customers. And out of that, we drive water efficiency programs and gamification or interest and reward over an extended period of time. And on the right-hand side, you can see a screenshot of one of the things we do, which we'll look again on the next slide for that one. We can move on, Olivia. So on this slide, you see the sort of customer engagement we're talking about to get that ongoing activity. So we're talking about it being native mobile apps. So it can be iOS or Android, it can be a laptop as well, it can be a desktop. Consumption data is displayed, but that's pretty much normal. People can see that anywhere really. But on the next one, you'll see in the center, target and goal setting and monitoring. So, whoops, can you go back one, Olivia, sorry. I mean the middle screen of the 5 that are here. You'll see that on the middle screen, there's a red line right in the center. That's actually the daily target that the customer is looking at. Below that, you'll see that there is consumption. In this case, my target is, 200 or so litres per day. That's actually a lot, in my opinion. I've actually been at 270, so there's a nasty red note saying that you're 70 litres above. Okay, so you can actually get that monitoring to the people, and you can send that to them in notifications. Hey, you obviously had too long a shower today, or maybe it was football day. And then the last thing you can do there is water education and water efficiency via programs. This is actually a real one out there. It shows people how they can modify their consumption pattern for water usage, and how that, and also educate them around that, so that in the future that they know that pattern goes. And you can continue to update those programs and challenges and reward people for that. Next slide. If we move on also to what the general public might be doing and how that affects your overall water operations, this is an example of street leak detection. So, and this is where it goes to a council or your water authority. This actually happened to me. I've been in the street locally. I've seen a water leak actually coming up out of the ground. Nothing as serious as this. It was a weekend. I rang my council. I got a voice line. So I left a note and I rang again on Monday, having left a voicemail. And they hadn't taken any action. They hadn't been able to do anything about it at that point in time. With a solution like this, you can select a button, which is report a water leak. It takes you to a page that explains, these are the steps, 1, 2, 3, take a picture, click submit. You'll also get rewarded for that. When you submit that, you think back to the earlier diagrams we saw, what that's doing in the automation process is it's going back out and it's going to your works team and it's sending them that information for this, so it'll appear in a queue. So on Monday morning, someone has a look, they can see the address, oh, that's definitely in our area. They can see clearly in the image, oh, that's a real problem. And then they can put that into the works queue to have someone go out and take positive action about that. So that this whole engagement is not just end customer engagement, it's also the engagement of your team and completing that automation loop in the activity. Which is great, yep, this slide's good. So the way Telstra approached this, again, it's not just providing you a water vertical solution. We're looking at this in a much more holistic fashion. We do a lot of this working with local councils as well as water authorities, because they're also water smart and water responsible. And so if you look across the bottom, if you've got that canopy out there of NB-IoT, and you've got that ability to collect the information and then use it via that digital engagement platform, you can then start to do other things as well. And you can pull in, you know, environmental monitoring, weather monitoring. You can be tracking with CCTV for security and things like that for some of your assets. And you can actually also do things like, you know, vehicle tracking and things like that as part of it. I won't cover all of these in detail, but the important message for this is that once you've got a solution like that up and running, and you've got an ability to engage your user base and your own staff, you can do it for so much more than just a water vertical for consumption of water meters. If you're a water utility, you can do it around other areas of your water assets that you're managing. And if you're a local council, you can do it for a whole lot of other smart community activities in the council. Okay.
Thanks.
And there's been insight there as well, Olivia. Thank you.
Thanks, Mark, for presenting. And before passing the ball to David, I'd like to mention that you can ask questions. There will be a session of quick Q&A at the end. So I'll let you now present. David, you are last, and you're also on the last time zone. So you are the latest of all.
Yes, it is. It is evening here in California. Hi, I'm David Howard. I'm with Itron Idea Labs, Senior Research Engineer, Solution Architect. And what I wanted to present tonight, you know, my fellow guests here have, our fellow presenters have gone into some detail about the transformation in water. And I'm going to kind of focus on how we get the data, how we get device manufacturers such as Itron and other manufacturers to make this transition in a way that you know, eases the ingestion of data, so we can have all of these outcomes. Next slide, please. So just a little background on Itron. Itron is a utility and IoT device and outcomes provider. It's grown out of acquisition of many years of companies in the electric, gas, and water metering business, as well as smart city streetlights, those sorts of things. Many generations of devices in the water space, everything from you know, mechanical non-remote read meters to walk by to drive by, you know, one-way communication devices back from the 1980s and 1990s into two-way communication devices, and all of them on a variety of different you know, vertically integrated proprietary stacks, as was the way of doing things in yesteryear, but many different platforms. Fairly large company, worldwide footprint, about 7,000 employees, and about 65 million, probably closer to 75 million by this time. This slide's kind of old. Endpoints that are under management, and about 200 million plus communication modules delivered. Next. I'm in a group inside of Itron, which is not one of the main business units. I'm in a business unit called Outcomes. And underneath that, there's something called Itron Idea Labs. We operate as kind of a startup within inside of the company. And it's an innovation group. We basically look for disruptive new technologies and new businesses, very rapidly explore them, try to scale them into a business that is interesting to one of the main business units, or kill it. So at any given time, we might have, you know, a dozen projects running in parallel, most of which fail. but a few of which succeed and do transition into the business units. Next slide, please. So just a problem statement here. How do we add, now that LTE, NB, and M1 cellular has matured to a point and has deployed at scale to a point where it can be potentially used and disrupt some of the existing wireless networks and methods that are already used for automatic meter reading and advanced metering infrastructure products. How do we add cellular transport to the existing product business units? We need to have something that is kind of SoC and MCU independent, because we have many different products. It needs a small footprint because, of course, some of these things were designed and built a decade or more ago, and we don't want to change something that's in mass production if we don't have to. It needs to be, whatever is used with cellular, we need low overhead. It needs to be power optimized because customers are used to in the water and gas space. 10 to 20 year battery life, certainly closer to 20 years in North America. And we would like to have a single protocol for all devices. The last thing we want is to have, yet another protocol that we're going to have to develop and support and patch and, for the next 15 years. There's a life cycle in utilities, as you know, is quite long. Once you just deploy something, you've got to support it for, the next 10 to 20 years at least. And how do we make it, how do we get something that's extensible, minimizes the touch for full life cycle. So from manufacture to distribution, to deployment, to operation, and then while it's operating. And we want to have something, that has a standard security approach, so we don't have to go through separate security reviews for each product, right? If we use a standard approach, it makes the whole process of getting something to general availability a faster process. And then last, it should be multi-cloud, public and private supported. A lot of utilities are happy to use a SaaS service, some of the smaller ones, but some of the bigger ones, they want to have their own servers, so it's private cloud. Next. And then some of the solution goals, we really want to avoid design, develop, test, patch, another custom-made proprietary protocol. We've got dozens of them already from acquisitions. And they're very expensive to maintain. We want to reduce time to market and development costs. A lot of devices, we don't build, we work with many partners. And, on the proprietary side, if we have to have partners developing to, a particular spec, it's getting up to speed, developing it, testing it, regression testing it, updating it, regression testing it. It's very difficult. So how do we minimize the impact on existing firmware on the device side and software on the server side, particularly the meter data management software that interfaces with billing systems in utilities. We want to utilize standard security approaches that are already understood by the IT departments, public key infrastructure, certificates, and standard security, IETF-based TLS and DTLS. We also would like to have potentially to be able to backport to existing solutions that are on different transports, LoRaWAN, Wi-SUN, etc. Next. So here's an example of a very simple water meter solution. This is a mechanical meter, and it has kind of an add-on attachment to it that allows for pulse output, as well as a wireless version of that same sort of thing. So, utilities can deploy the meters. They can add the AMR plus kind of features later, or they can deploy them and add it at the same time. The wired version, whatever the comms are, they don't necessarily have to be located exactly where the meter is. They, if you have a meter pit or you're inside, you might have the comms located remotely from it. The wireless version just snaps right on the meter. So in this case, you're creating an LTE NB-IoT version of this that interfaces to pulse output sensors and meters, basic register, some basic alarms, and ability to change the update interval, firmware update, some things of that nature. So it's not as primitive as just automatic meter reading. It's automatic meter reading plus configuration and firmware update with security. Next. So from a high level, doing this with lightweight M2M, the hardware kind of looks like this. The top one is what we were just looking at. So that's a 2 or 5 wire interface. It has essentially a high frequency, low frequency pulse output, a tamper detect or a cable cut, and a direction signal. So basically 4 signals coming from it. Can interface that very easily to LTE modules. In this case, I used a Nordic NRF 9160, but you can very easily use other cellular modules as well. And the ability to embed a lightweight M2M client directly on those devices, such as the IOTEROP client, is really quite nice, and to be able to add enough code to be able to handle the GPIO interface for the sensors, and basically you have a solution. It doesn't take man years to develop it. It's man weeks. It's very straightforward, and on the other side of the equation, you end up with a SaaS or a cloud-based server, REST APIs and callbacks, and then the ability to use very simple code, streamed code or serverless code to move the data on to your meter data management system, or accept data and move it from the into the Alaska server and back out to the devices for configuration. The other nice thing about this is that we can very easily move on to the full wireless adapter, and then even potentially move on to a fully integrated unit, all with the same protocols, all with the same management system, truly the same sort of system from one device to the next, without having to develop anything new. Next. So what did I support on this? For the proof of concept that we did on this, basically the standard objects from OMA, which give you your server object, your device model object, connectivity monitoring for NB, and firmware update are really all that was necessary to make a kind of minimum functional device. Of course, you can add to that, but that's a great start, and those are all kind of built in. Next. And then for the 4-wire interface, one of the nice things about lightweight M2M and OMA IPSO is there are objects that are already defined. There's some really simple ones, which I used in this case. One was for level values, the switch object, used for cable cut and flow direction. And essentially, those are like alarm events. So as soon as they happen, the message is sent, right? Even though it's a sleepy device, those are basically wake up events, and they cause a message to be sent immediately at that point. The push button objects they used for the low frequency pulse and the high frequency pulse. Low frequency is basically your register. It's a count up only pulse, and the high frequency one is if you are trying to understand directional flow, like reverse direction flow or forward direction flow. In high resolution, you could collect that data on demand, but normal operation you would just be getting a pulse count as a register at some interval. It might be 15 minutes. You might collect 15-minute interval data and only send it once a day. All of those are things that you can do under management control through lightweight M2M. And show the next one, next slide. Just to give you some detail of what those objects actually have in them. So they have some mandatory attributes. They have so it's basically the state, whether it's on or off on the switch or and then a counter to tell you how many times it's actually gone. Those are the pulse counts. So there's a timestamp, so it tells you the last time it was updated. These are kind of default objects. You can extend these very easily. That's one of the nice things about lightweight M2M is objects are basically defined in a public repository. You can have private objects if you want to, but you can reuse public ones. You can edit them, and by just using the URN, you can essentially have software on the server side that fully understands, what the objects are, what the attributes are, what format they're in, so it can display, manipulate, graph, store in a database, whatever you want, without having to write any additional code to do that. And essentially, what you get from the servers is JSON strings, which are super easy to for any cloud developer to work with. Next. On the server side, you essentially have RESTful open APIs. So there's no more SOAP interfaces or proprietary interfaces on the server. You have Swagger or Open API RESTful interfaces, which all web developers or cloud developers are very familiar with, and tools to manipulate them, and test them as you're writing your code. So there's APIs for provisioning, getting device lists, getting device objects and attributes. When a device registers with the server, it basically enumerates all of its capabilities. So the server automatically then knows what it is. You can request that information, read write updates, callbacks. So when data is sent, it will do a callback to a specific routine, give you a JSON that's the operation results. All very straightforward interfacing. Next. And this kind of hard to see, but this is kind of the output that you would get from one of these calls. This was a call to list all devices, and it returns standard JSON objects, endpoint name, version, status, the lifetime of the registration, when it was provisioned, and then a list of all the objects that are available on that particular device. Next. So that's a very simple kind of AMR plus approach. If you want to do, the next kind of step is, if you really want to have advanced services and outcomes, you might need a more advanced meter interface. So a fully integrated solution probably needs a little more data. So you might need daily register data, interval data, events, alarms. You know, the update interval be flexible, different programmability, you know, leak detection, you know, even edge, you know, firmware running to do things like leak detection, the firmware update, configuration, maybe even remote valve close. So once you get to something that's a little more complex like that, then it behooves you to, you know, either create new objects and attributes, or again, you know, look at what's already out there. And if you look at, if you flip to the next slide, you'll find out that there's, you know, several people who have already done work in the water meter space. So one is a group called Usify, who already has a water meter object with, you know, a lot of the, you know, a lot of the things that you might be interested in having. And they have irrigation valves, pressure, and water quality, all with a lot of attributes that are defined that you can build out in your device, and that will automatically enumerate and be available on the server side. And then the next one you'll see is our friends at, ooh, look at that, Southeast Water. They've actually defined a very extensive set of objects for water. I think more than 20 that have been published so far. This allows you to, you know, really fine tune the management of your water solution, and take advantage of, you know, some of the features that were mentioned in the previous presentation that were related to leak and flow and much more. So they're very sophisticated objects, and even have objects that support links to other objects. You can have lists of things. The point here being is that the underlying you know, protocols that support all this are the same, whether you're doing a very simple approach or doing a very feature-rich approach. You don't have to be an expert at security and PKI. You don't have to be an expert at protocols and retransmission or firmware updates or any of that stuff. You essentially work at the object and attribute level, and rely on the underlying clients and servers to handle the bootstrap, the configuration, the enumeration, the read, the write, the send, the notify, all of that handled in one standard way. Next. So why didn't we do this before? Well, there's a couple of reasons. The original lightweight M2M 1.0 had some shortcomings with respect to low energy and sleepy devices. I'll, you know, full disclosure, Itron is very involved in OMA and lightweight M2M and IPSO. We have chairs and secretaries in both organizations, and we are involved in many standards bodies. But in this one particular, you know, we looked at it very early on. We ran into some issues that we saw were not, you know, while lightweight M2M looked like it was working very good for carriers for the management of the modems, management of the actual devices and data orchestration, particularly for battery devices, had some shortcomings. So in 1.1 and 1.2, some of those were fixed, and some new features were put in to really help with things like water meters. So the bootstrap and registration interfaces were optimized to reduce overhead and the number of messages back and forth. There is a addition of something called a send operation. Originally, you couldn't, a client device couldn't wake up and just send data. It had to actually be requested from the server side. So now it has the ability for a data push. without an explicit request. There are read and write composite operations, which, you know, if you have many objects and attributes and instances of those objects or attributes, you may only want a small set of those to be read or written at any given time, and not the whole object. The composite operations were introduced, which gives you a more surgical precision on data operations. Again, reducing the payload size, so keeping the tariff down, but also the main reason for that is energy, right? Because the longer you're on, especially if you're transmitting, you know, the more energy you're burning and harder to keep the battery alive. And then a really serious one was a problem with DTLS. We added connection ID for efficient security context resumption. So one of the problems on the internet, particularly with public APN on cellular, is everything is going through firewalls. And this is true going into cloud servers as well. But those firewalls, you know, essentially when you start a UDP session, well, when you open UDP to send data, it punches a pinhole through the firewall, and it DTLS does its handshake. It records the source IP and the port and some other information. When you stop sending data, about 30 seconds later, that pinhole closes. So even though you've already gone through your, you know, security context and your registration to your lightweight M2M server, the pinhole closes. The next time you try to send something, either from the server or the client, it's not open. It has to go through a full registration again. It has to go through a full security context again. Literally, you know, 500 to 1,000 bytes later, you're back sending data again, but, you know, maybe you were only sending, you know, 10 bytes, right? So you waste 1,000 to send 10. So connection ID fixes that problem. Another way to do it, of course, would be to use TCP, because you can keep the session open, but that has other implications which are not good for battery. So fixing it for UDP was a good thing. CoAP over non-IP or NIDD was added. This essentially removes the IP wrapper and relies on the 3GPP security over the network. That's very useful in reducing not only the overhead to register to start a session, but while you're sending data, because you don't have the additional security wrapper or IP wrapper around the data. You're relying on 3GPP network to secure it. And then for end-to-end security, you can use something called OS Core, which I'll mention later. New support for different ways of serializing the payloads that were also compressed. And then a gateway functionality. You know, you want to use UDP when you're talking from a device over the cellular network to minimize overhead and reduce energy. But unfortunately, the cloud providers don't like UDP because of the firewall business I mentioned. They can't tell when they can shut something down. With TCP, they can, because there's a timeout, and they can also see that you close a connection. Because UDP is connectionless, they don't know if the connection's been closed. So that's why they have such a short timeout. And so if you have a gateway function, then if you're interfacing with like IoT Hub or IoT Core, there needs to be a way to transition from UDP to TCP or UDP to HTTP to communicate with the, or even MQTT with the IoT Core or IoT Hub. So that was added. And then application layer security based on OS Core. So all of those things were added kind of as a a learning process from Lightweight 1.0 in order to support things like water and gas meters. And Itron is very interested in the industry moving toward this more standardized method and enabling us and others to take advantage of the now very large and ubiquitous NB networks that are out there. I think that is my last slide. That's right. Is there a next one?
David, it is the last
okay.
one.
All right.
So
thank you.
Thanks, David. So there are a couple of questions that are for you. So I'd like to maybe, and as they are in the continuation of your presentation, there is a first question from Kwan Mang Ko about asking about is NB-IoT more popular cellular technology compared to Cat-M1, and is it because of coverage? Are there any other reasons related to use Narrowband-IoT rather than Cat-M1?
Sure, I'll take that. I think Cat-M1 was the early favorite, certainly in many countries. It was easier for the carriers to deploy. It's basically based on the same architecture as the LTE that they were already deploying. From an energy use standpoint and a range standpoint, and this is a little bit my opinion, since I don't have a lot of stuff deployed on NB yet, but I think we tend to favor NB as the solution, particularly in Europe and Southeast Asia. It seems like that's the winner. In North America, we're building stuff that works on both M1 and NB. I will say that on NB, one of the problems we ran into and are still running into is roaming agreements. So very hard to have a single solution and be able to send it multi-region. Super difficult.
Okay.
Whereas M1 is easy. It basically works everywhere.
Mark, do you want to add something to that on Cat-M1 versus NB-IoT?
Yeah, pretty much aligned. I would say, NB did follow later on. It is normally used for smaller data packets than Cat-M1, and typically we find we're normally using devices on Cat-M1 that are powered, although it's equally suited to battery-powered devices. We're finding very good range out of both, significantly more than you would get out of an ordinary signal, which is really good from a 4G perspective. And we do find that NB-IoT really does give you a capability to get an exceptional battery life. So as long as you've got the battery management, down pat, being ex-Itron, I can say that it's one great skill that Itron always had was battery management. But they're the main things. I'm happy also if anyone wants to reach out, we can sort of give you a comparator between Cat-M1 versus NB-IoT. But I'm sure your local carriers can do that as well.
Another question also, I think for David here, related to the IPSO objects usage and any cost, if there is any cost associated for using already defined object. I think that
no, there isn't. So it's really a great question, but no, there's no cost at all for those objects. The ones that are published in public are free for anyone to use or to use. And create new objects from, so modify them, reuse them. And like I said, in the water space, Southeast Water has really done an extensive set of objects already. I think it's a great starting point. Usify is probably also decent. But it's pretty easy to make them too. The IPSO, OMA IPSO has an editor built into their web page. It's very easy to just create your own if you want to. You can request a block for your own use of your company if you want to publish, you know, and reserve kind of private space for your own objects. But I would strongly recommend you just reuse ones that are already there.
Yeah, and yeah, I'd like to add that yeah, IPSO objects can be contributed, so you can contribute to that, and there are the organization considering that. So this is an important point, that everybody can contribute to those objects. There is another question that raised up about about if there are any implementation of lightweight M2M over over NIDD bearers.
Yeah, IADROP.
Yeah. So
not a lot of carriers support it yet. That's actually something that we're in the process of exploring. So still kind of experimental, but looks very promising. As a way to you know, further reduce overhead and energy consumption. But I, you know, have to admit at this point, I don't have anything running live on that yet. Probably in the next 2 or 3 months I will, but not quite yet.
We have done and started at IoT Europe. We have done and started tested at in partnership with Dutch Telecom. So
yeah, that's one of the carriers that does have an implementation. Yeah.
There is a question about there are 2 questions that are kind of very close. There is a question, the first question actually, what role will real-time data play in the future? And the second question, which is on how high is data collection rate on the water meters, and will they collect data like each 30 seconds or even slower or faster, or do you have concerns to which band with limitation if scaled to millions of devices? To that question, it's important to remember that water, at least water meter devices, water sensors are all close to water, and so most of them, for security reasons, are on battery for that very reason. So real-time data is very scarce, at least from our experience. But maybe David, you can take the questions, or Mark further.
Yeah, we aren't looking at collecting data at 30-second intervals. There is, I think one of the things that was mentioned previously was the ability to, with lightweight M2M, to change the configuration of the device. So normally we would be gathering like 15-minute to 1 hour kind of intervals, and then transmit. If nothing was outside of normal operation, we wouldn't transmit that except once a day, right? But if something was unusual, like there was unusually high flow, or the customer asked, you could certainly change it to do measurements at a higher frequency. The trade-off there is battery life. And certainly if you wouldn't do it on the whole network at once, because, again, as was mentioned, NB-IoT is really, designed for, many devices sending very small data packets. And if you have many devices sending a lot of data, I think you tend to flood the network pretty quickly.
Mark, do you want to say something on that?
Yeah, I would say that we're definitely not so far looking at 30-second data. I think Andrew could also comment, from their side. We do have some instances where we are using, well, we refer to it as high-speed sampling, which is more to do with, commercial and industrial and leak detection type scenarios.
Yeah.
But that is, 1 minute through to 5 minutes, certainly not at that level. And that's not continuous. It's normally done for a set interval to achieve an objective around that assessment. We are generally collecting, somewhere between, 650 and 800K in a year if you're using lightweight M2M across the meters. If you're collecting 30-minute, 1 hour interval data and picking it up once a day. So we're not seeing any, certainly on our network, any issue there around bandwidth limitations from that perspective. But yeah, high frequency sampling is a slightly different use case that we find is not that prevalent on the network. Andrew, do you want to comment on that from your side? Or?
Sorry, Mark?
I just wondered whether Andrew wanted to comment from his side.
No, Andrew left, so alas, he won't be able to comment. There is one last question, I think that for David, that Andrew is asking about AMI standards for measuring payloads, and his question is that it seems that many lightweight M2M meter devices use object 19 or 10 to 50 or for binary 20 to 50 or binary app payload blobs, uplink and downlink, which is opaque. And when we'll see an AMI standard lightweight M2M object promoted in ETH GitHub IPSO dictionary? And I think that you mentioned AMI, and I think that's an important part. But is there a standardization going on to make AMI devices taking into account with lightweight M2M?
Yeah, it's yeah. The short answer is I don't want to use binary blobs for anything, because I think that really limits the utility. I mean, you still get a lot of benefit from lightweight M2M, even if you're wrapping some other protocol. And I think that's what people are doing with binary app payloads. They're basically taking some legacy protocol and just transporting it with lightweight M2M. So you still get a lot of device management capability, but from an application, data utility, sending binary blobs is not very useful. So I'm not doing that. I will, the plan. There are several plans that are in flight right now to do things as crazy as creating new objects that have like COSM OBIS objects defined in them, so that you can be compatible with kind of legacy utility protocols like DLMS COSM. Just lose the DLMS and just use the COSM data objects so that you can be compatible with some of the management software, the legacy software that's out there. That probably is going to happen. But what I would like to see is, between some of the companies coming up with, a really clean set of objects, kind of like what Southeast Water initial work was on the 1.0. But maybe a refinement of that people will start to use. But I'm not aware of any consortium or individual company that's setting any industry standard on that yet. It's still kind of the wild west, unfortunately.
Okay. Thanks, David, for your detailed answer. Andrew Lecky is asking another question about battery. I think that you should look at object 3411. There is an object that indicates some energy cell parameters and some of the battery chemistry. It's still left open, but yeah, there are gaps, to answer to Andrew, on defining objects like energy cells or battery inside the definition. Those object battery has been contributed by UCFI. Any organization or company can contribute, and those objects will be reviewed and added. It's a very simple process to enter in. Long but simple, so don't hesitate to do it. But yeah, I think that object 3411 is matching some of your requirements you just put forward. So I think that we have gone through a good set of questions. I thank you all the attendees to be participating till now. Thanks for your attention. This webinar has been recorded, will be provided with the slides later on. And I'd like to thank you, Mark, for participating. Thank you, David, for participating, and thanks, Andrew, who left, but thank you, Andrew, for your participation. Have a good continuation of a day or night, wherever you are. Thanks. Bye-bye.
Bye-bye.
Thanks, everybody. Appreciate it.